So if you remember our last example, even when we did an experimentation, we took only 75 people, and from that 75 people we look at that what exactly is that ball game, right? Or even for the commute time, we were taking a small set of people and it was working. But now imagine the employee size is not 75 or so, but maybe it is 30K. Okay, so we have 30,000 employee for whom basically with the help of whom we want to find out the average commute time for my whole company. Now doing the survey for all 30,000 people is almost impossible. Even if you think about an example of election exit polls, there also companies only take a sample, and from that sample they do some inference. They don't go to all the population available. Similar way, now we have a problem. We have 30,000 population size, let's say, which belongs to Tech Love company, and there are 100 employee for which we have done survey and got the mean of 36.6. Now this mean which we have got is called as sample mean and is going to be represented by this X bar. On the other hand, my population mean will be represented by nu. Now how confident you can be for this value 36.6 to convey something about my population mean? Can I say that since I got for 36.6 mean for 100 employee, so I can say that for my whole Tech Love company having 30,000 employee, the population mean will also be 36.6? Definitely a big no. We will see to that how we can use some other terms to basically give more confidence that okay, what we can really say from this number 36.6 for my population mean. We will talk about that. Now, in this case, my sample mean is going to, sample size is going to be called as 100. Okay, so which is denoted by small n. Capital N means that my population size, which is 30,000. Let's say S denotes my sample standard deviation, means the standard deviation for my 100 employees. Let's say this is the value for it. Now let's compute it. Since I know my 100 employee, I know my actual value for them and the mean value for the 100 employee. Let's say I computed this value xi minus x mean the whole square. If you remember, this was a part of variance. Now let's say I got the value 9900, and after that I try to create the s square value, which is variance, and let's say I got the value xi minus x bar square. Now there is a small change in the formula. If you do remember, your standard deviation formula used to be I going from 1 to n xi minus x bar whole square divided by n. But this was true formula when you had a population mean. Okay, sorry, population standard deviation. This is basically for your population standard deviation. When we talk about a sample, means when I have taken a subset of the data, my formula changed to n minus 1. Now, I am skipping the maths part for it, that why this have happened, because this is too complex. So I'm keeping it outside the scope of this course. But in case if you are interested, please do not hesitate to post in the discussion forum. I can provide you the link so that you can follow more details on the mathematics why this have happened. But I would strongly recommend that it is not really required. Again, the math section what you are learning, again I'm repeating it this point again and again. You should focus on more on the machine learning part, that what are the maths will be required for me to understand the machine learning part well. That will be our main focus here, rather than basically talking about all these things in mathematical proof side. So proof sometime just Definitely it's important, I would not deny that, but at the same time, from the machine learning point of view, if you ask me, may not be that important. Okay, let's go ahead. So in this case, my value going to come out to be 9900 divided by 99, because n was 100. I will get the output of s square as 100 value. Now this is the part which we are going to get. Now, with the knowledge which we have just gained, let me take another use case. We have not yet solved this problem, okay? We will come back to it anyway. Let's say, I am pretty sure all of you must be using Facebook. Everybody must be using Facebook. Now, if you look at the Facebook basically want to, let's say, they keep on changing their timelines, right? So sometime you might have noticed that sometime they do change the timeline, not every time, but yeah, sometimes you see that they may be changing the theme or doing such sort of activity. In fact, you might have also noticed sometime when you are scrolling your timeline, they will give you a question. Do you think this is relevant? Do you think this is being liked by you? Something like that. And you have to say yes or no, and let's go away. Now let's say Facebook decided that they want to test a new feature before launching it. They want to test it because they want to ensure that people are going to like it. Now the thing was that when they decided to do something like this, they took a sample. Definitely it's impossible for Facebook to go and ask all the 1.86 or I think 2 billion set of users to do a survey. It will be too much. So what they did, they took out, let's say 10k users, okay, 10k users randomly, and those 10k users they asked to did a survey, and they asked that whether you are going to like a new feature B, which is the new timeline. Okay, this is feature B, not Facebook. So let me note down properly so that you should not get confused with this. This is feature B, which is a new feature. Okay, this is a new one. So this one, or feature A, which is the old one, which is you are going to like. Okay, so which one you prefer? So let's say there are 50.5% of the people who said that they preferred feature A, and there are 49.5% of them which preferred the old feature. So based on this survey, Facebook can say that feature B is preferred by more people than feature A, and hence they can go ahead and replace it. So here, by sampling, Facebook found that feature B is preferred, right, and not feature A. And we have done this exercise on sample and not on the whole population. So what are the advantages you have achieved here? Facebook saved a lot of time, they saved a lot of money, right? And basically they could now get some result out of it. But hold on. How can you be so sure that the insight inferred for the sample hold true for the population as well? Because I can't really say with this just 10k users that my feature B is better than feature A. In other words, just because 50.5% of the people in the sample is preferring the feature B, is it really fair for you to infer that 50.5% of the people in the population, okay, when I say population, there are almost like 2 billion users, I'm not very sure about the number, are going to prefer the same? You cannot really answer this question with the information you have right now with you. However, after the next few video lectures, which will cover some other topics like sample distributions, central limit theorem, and confidence interval, you will be in a situation to answer all these questions as well. Sounds interesting, right? Let's go ahead and learn all those topics.